Hello everyone. It is October the 24th, 2015, about 8:30 a.m. And we're going to talk a little bit about the effects of El Nino winters at Reagan National Airport. I did an earlier video about this, but we're going to go into some pretty deep analysis about what happens during El Nino winters and non-El Nino winters. And I want to show you what I've done. I actually have been able to get a data set from the National Climate Data Center. This is the data set, and actually it's in an Excel spreadsheet. There's over 12,000 individual data points because this data is daily data from 1980 through 2014. So it ends up with over 12,000 sets of data. And I actually did this because I noticed in my previous video there were some things that were puzzling to me. Some things that I just wondered if I drilled down and carefully analyzed on a day-to-day basis during El Nino winters and non-El Nino winters, if it would provide a little more insight into what was going on. And as it turns out, it does. And a lot of the insight flies in the face of the common wisdom of what happens in El Nino winters. So I want to share some of this analysis with you. Okay, what you have up on the screen right now is the median precipitation in inches by month at Reagan National Airport. Now, I should give you a little statistical background. There are two things I'm sure you've heard about: is the median of a data and the average or mean of a data set. And the difference between a mean and a median in data, if the data follows a normal distribution, they will be equal. There'll be no difference. So most people assume they're equal and simply use the average or mean value of the data set. However, in most natural data sets, the data is not, it doesn't follow a strict, perfect normal distribution. It's usually skewed one way or the other. And so as a result, it actually is more robust to analyze data to use the median when you really don't know how well it fits a normal distribution. So that's what we're going to be discussing right now, is the medians I have found in that 12,000 plus data set. Okay, what you see on the screen is the median precipitation in inches by month at Reagan National Airport. And it's divided into non-El Nino years and into El Nino years. The non-El Nino years are blue. The El Nino years are red. And if you notice on the graph, I have the number of members in each of those subsets. Non-El Nino years is 22 years, and El Nino is 10 years. And that's taking the data set from the 1980s through 2014. Okay, for the precipitation, comparing the two conditions, Novembers are substantially wetter in El Nino years compared to non-El Nino years. And that's this over here, showing that in an El Nino year in November we get a median of more than almost 4.5 inches of rain. I should say precipitation, can be rain or snow. And in non-El Nino years we get about 2 inches of precipitation. December through February are slightly wetter in El Nino years compared to non-El Nino years. And you can see that here we have 2.81, here we have 2.78, which is higher than the blue. Here we have 2.52, which is higher than the blue. And so December through February, we do get slightly more precipitation in El Nino years. However, after February, in March and April, we end up with actually less precipitation in El Nino years compared to normal El Nino years. So it suggests that in general, at least the first part of the winter in an El Nino year will be much wetter to about the same as far as precipitation goes, at least through February. Okay, the next thing we're going to look at here is the median below freezing days by month. This is the number of days in which the low at National Airport was at 32 degrees Fahrenheit or less. And the reason why that's important is that you need at least 32 degrees on the ground before snow will accumulate. So potentially the more days that are 32 degrees or below, given random distribution of precipitation, the more chance you have of snow. Okay, comparing again El Nino years and non-El Nino years, there's a better chance for more winter days with low temperatures at or below 32 degrees Fahrenheit in El Nino years. That means if you look at the graph here, November there's slightly more chance of days with below 32. December we have less here at January, but much more in February and much more in March. So in general, there are more chances through the winter of having below freezing days. This actually calls into question that El Nino produces a warmer winter. We're showing that we're going to have more days 32 degrees or less in an El Nino year, and that's certainly not indicating a warmer winter. The other thing that you can see from the graph is that the El Nino years extends the time for maximum number of below freezing days. January and February in El Nino years have about the same number of the median number of El Nino days, which is 20 below freezing days, while the non-El Nino peaks in January at 22, but has substantially less by February. So again, this is really showing that El Nino, at least at Reagan National Airport, does not mean a warmer winter. Okay, this graph shows the mean snow to liquid ratio, abbreviated SLR, by month. And the snow to liquid ratio, if you know the old saying that for every inch of rain you get 10 inches of snow, that's the ratio we're talking about. And the climatological average for the DC area is about 11.8 to 1. The interesting thing that came out from this study is that in non-El Nino years, the median of, and that's in the blue here, the median of that ratio is far less than the accepted climatological ratio of 11.8. So certainly in non-El Nino years, it's probably not going to be an 11.8 ratio. It's going to be probably more in the neighborhood of 9 to 1 ratio for Reagan National Airport. But the other thing that is really clear from this graph is that the SLR substantially is higher in November, January, March, and April in El Nino years compared to non-El Nino years. The SLR is substantially lower in December in El Nino years compared to non-El Nino years. And that's what we're showing here, is that every year in El Nino, the ratio is actually higher than the non-El Nino by a good amount, except for December. Okay, the SLR is the same in February, and basically you see that they're both about somewhere between 8.9 and 8.5. Now, what this suggests is that in El Nino years, you certainly have more chances of for months in at least January and March for a much higher snow to liquid ratio, which suggests that in El Nino years you have a better chance of what's referred to as fluffy snow, a small amount of precipitation producing a large on the ground amount of snow. And that absolutely is contrary to accepted opinions on for El Nino winters. The general consensus is that it will produce a wetter snow in the winter, and the data doesn't bear that out. Okay, this is probably the most dramatic difference of any of the analysis. This is the median inches of snow by month in both El Nino years and non-El Nino years. And as you can see, in January and February in El Nino years, you get a substantially higher number of inches. The median is substantially higher for El Nino years. So we observe that we have far greater chance of large snowfalls in both January and February in El Nino years compared to non-El Nino years. The chance of a large snowfall peaks in February in an El Nino year. And if you notice, this is what I'm talking about, is that January in a El Nino year, you got about 4 inches as the mean. Up here you have almost 6 inches as the mean, and then it drops back to nothing. Okay, so it does peak in the February time frame. The chance of a large snowfall peaks in January in non-El Nino years, and we're talking about the blue part. As you can see, it comes up to about 3 inches in non-El Nino years, and then tapers off very rapidly in February. Okay, next we are going to look at the median snow days. This is the number of days the median number of days in which there was snowfall recorded, and that's done on a day-to-day basis in the analysis, and then is rolled up into monthly figures. A greater chance of snow days in December and January in non-El Nino years. So what we have here is we have a greater number of snow days in January, and as a result, again, it confirms that we get the peak for non-El Nino years in January. There's a greater chance of snow in February, as you can see, in El Nino years. So what this is showing, I think, my personal opinion, is that in El Nino years, the severest part of the winter is shifted back towards February, rather than having the severest part of the winter in January in non-El Nino years. Okay, that's the conclusions that I've reached so far. Again, I'm still doing more statistical analysis on the data set, and I'm trying to find out exactly if there's any other indices that is affecting the temperature at the Reagan National Airport. But I think we can definitely conclude here that El Nino years are not warmer for winter in the Reagan National Airport area, and but there is a suggestion that it is a wetter year in El Nino years at Reagan National Airport. And I should just emphasize, I'm sure you've read that on the screen, but the conclusions that I'm presenting here only apply to Reagan National Airport. I suspect that if the same analysis is done for each weather station around the country, you're going to get a different result. And that is because of the local topography and heat island effects and other things like that, how far north Reagan is compared to other stations, closeness to the river, a lot of factors that are very local to the data set that I'm analyzing. So you shouldn't extrapolate this to everything in the United States or everything on the East Coast, but it definitely shows what's happening at Reagan National Airport. Okay, if you have any questions about the weather or about this analysis, give me a tweet at PatPend, that's PatPend, and I'll try and answer them. Thanks a lot.